Today we are going to discuss multiplying and dividing radical expressions. So here's a couple of examples. First, square root of 6 times square root of 3. Because the 6 and the 3 are both under the radical, they can be combined into the square root of 18. Now we need to think about, can we simplify the square root of 18? Can we split this into a perfect square times something else? Like 9 and 2?
Oh, yeah.
And the square root of 9 is 3. So this is 3 times the square root of 2. Okay, I did hear a quick question. Where did the 18 come from? 6 times 3 is 18. If they're both under the radical, you can combine them, which leads us nicely into B, square root of 2 times 4. Is the 4 under a radical?
No.
No. So we can't actually multiply them. We can just put them next to each other. So square root of 2 times 4 is 4 times the square root of 2. Square root of 2 times negative square root of 8. The 2 and the 8 are both under the radical, so that becomes the square root of 16, and there's a minus sign in front. What is the square root of 16? 4. So we have 4 square root of 2 minus 4. Because this 4 doesn't have a square root of 2, you can't combine them. It is 4 square root of 2 minus 4. They are not like terms. I want you to try C on your own, and we will check it in a minute. Pause the video. Pause it. Pause it. Okay, so here's where most people get stuck. Square root of a times 4 is 4 square root of a. Square root of a times negative square root of a is negative square root of a squared. Well, think about that. Square root of a squared is just a. So we have 4 square root of a minus a. A? Sorry, that was a Northeastern Iowa thing. I just had to throw that in there.
It's more Canadian.
It's Northeastern Iowa, but you know. The thing that you need to know here is that when you have the square root of something times itself, it ends up becoming just that number under the radical. So as a shortcut, if you see like, let's say you see square root of 5 times square root of 5, you know that that would simply be 5. Square root of 9 times square root of 9 would just be 9. All right. It's actually example 2, but whatever. In this example, we have a binomial times another binomial. So we need to double distribute or FOIL or whatever it is you call it. So we start with 2 square root of 7 times the square root of 7. You've got 2 times the square root of 7 times the square root of 7. What's the square root of 7 times the square root of 7? 7. So this is 2 times 7. So 14. If you wanted to go ahead and write 14, you could. Next, we've got 2 square root of 7. I wanted that to be orange, not red. Come on now, pens. Work with me. 2 square root of 7 times 1 is 2 square root of 7. Next, we've got negative 4 times the square root of 7. You can't combine those, so you just write them next to each other. And then we have negative 4 times 1, which is negative 4. And some of you already replaced this 2 times 7 with 14. That's fine. So for like terms, we've got 14 and negative 4. What is 14 minus 4? 10. And then we have 2 square root of 7 minus 4 square root of 7. 2 minus 4 is negative 2 times the square root of 7. Sorry, that orange really doesn't show up very well on the green, does it? Sorry about that. I won't use orange anymore. Okay, in B, you have to think about the fact that this is really 3 minus the square root of 2x times itself. 3 minus the square root of 2x. So you need to double distribute or FOIL the same as we did before. So first, 3 times 3. That's the easy one. You're right, it's 9. That was overwhelming. They were all so loud that we couldn't even hear it. That's amazing. Oh, well, there's some people making noise up there. 3 times the negative square root of 2x would be negative 3 square root 2x. Then we have negative square root of 2x times 3. That would be another negative 3 square root of 2x. And then negative square root of 2x times negative square root of 2x would be positive 2x. No, don't go to the next one. Okay, so up here I'm going to write negative square root of 2x times negative square root of 2x. The negative times the negative is the positive, and this would be square root of 4x squared. The square root of 4 is 2. The square root of x squared is x. So negative times negative is positive. The square root times itself is just that thing without the radical. Okay, like terms. I already color-coded the like terms. The only like terms are the negative 3 square root of 2x's. So we have 9 minus 6 square root 2x plus 2x. It's kind of frustrating that there aren't more like terms, but we can deal with it. Okay, when we divide, we've got 4 divided by 2 minus the square root of 3. The problem is we cannot leave this expression like this because you can't have a radical on the bottom of a fraction. So we are going to multiply both the top and the bottom by the conjugate of the bottom. The conjugate is exactly the same as the bottom with the opposite symbol. So this says 2 minus the square root of 3. The conjugate would be 2 plus the square root of 3. And we're going to multiply that on the top and the bottom. As long as you multiply both the top and the bottom by the same thing, you're not changing the value of the fraction, you're just manipulating the numbers. On the top, let's distribute. 4 times 2 is 8. 4 times the square root of 3 is 4 times the square root of 3. On the bottom, we've already had practice double distributing, so this should be pretty easy. 2 times 2 is 4. 2 times the square root of 3 is positive 2 square root of 3. Now let's distribute this negative square root of 3. Negative square root of 3 times 2 is negative 2 square root of 3. And negative square root of 3 times the square root of 3. Anyone want to take a guess? Negative 3. You've got negative square root of 3 times square root of 3. So you've got negative square root of 3 times square root of 3 is the square root of 9, which is 3. So that's where that negative 3 came from. Whoopsie. Okay, combining like terms. On the top, we have 8 plus 4 square root of 3. On the bottom, do you see anything interesting about those 2 blue terms in the middle? They're the same, except one of them's positive and one of them's negative, which means they cancel each other out. And all we have left is 4 minus 3, which is 1. Do you need to write the 1 on the bottom? No. Totally just heard an uno. It's funny if you're in my 4th hour. If you're not in my 4th hour, you probably don't get it.
If you know, you know.
If you know, you know. If you don't,
You know.
you don't, I guess. On this next example, what do you say we do the most complicated one, and if we get that, we're probably good?
Okay.
Deal?
Yeah.
So let's do B.
What do you think about that, Jake?
What is the conjugate of this one? Square root of 7 plus square root of 5. So we are going to multiply the top and the bottom by square root of 7 plus the square root of 5. Notice the conjugate is exactly the same as the bottom, just with the other symbol. So if you start with minus, your conjugate is plus. If you start with plus, your conjugate is minus. Really quickly, over here on example A, what would be the conjugate on example A? 4 minus the square root of 5, just so that you've got a little bit of practice finding that conjugate. So in B, let's distribute. 6 square root of 5 times square root of 7. The only things you can actually multiply together are square root of 5 and square root of 7, which is square root of 35. So 6 square root 35. 6 square root of 5 times square root of 5 would be 6 times 5, or 30. So taking that up here, we have 6 square root of 5 times the square root of 5. That really just becomes 6 times 5. That's where that one came from. On the bottom, let's double distribute. Square root of 7 times square root of 7. No, go back. Square root of 7 times square root of 7 is square root of 49, which is 7. Remember, a square root times itself is just that number. So square root of 7 times square root of 7 is 7. Next, square root of 7 times square root of 5 is positive square root of 35. Now we have to distribute the negative square root of 5. Negative square root of 5 times square root of 7 is negative square root of 35. We use the conjugate because of that plus minus. Do you see how those two middle terms are going to cancel each other out? Yeah. Because one of them is plus and one of them is minus, that's going to happen every time. And then our final term that we have to distribute, negative square root of 5 times the square root of 5 is negative 5. And if you need a little reminder, negative square root of 5 times square root of 5 is negative 5. That's where that comes from. Okay. On the top, we have 6 square root of 35 plus 30. On the bottom, the two middle terms cancel. 7 minus 5 is 2. If you leave your answer like that, you will only miss half a point. Does anybody see anything else we could do? I want you to focus on the whole number pieces. So, that was not good. The 6, the 30, and the 2. Do 6, 30, and 2 have anything in common? 2. 6 divided by 2 is 3. 30 divided by 2 is 15. So you can divide all of the whole number pieces by 2 to simplify it. That square root of 35 is stuck under the radical, so you can't touch it. But the 6, the 30, and the 2, those are all whole numbers, so you can simplify those. Give me a thumbs up, thumbs down. How do you feel about this? Okay, that's decent. On your assignment, I've changed it slightly. Basically, we're not doing 60 through 64 evens, but I am adding in number 62. So number 4, 12, 20, 28, 30, 52, 54, and 62.